In this problem, we start with a fairly complicated function, the arcsine of x plus x times the square root of 1 minus x squared. What's going to be interesting about this is that we end up with a much simpler derivative than we started out with for a function. Let's see what happens. We know from the formulas we've just received that the derivative of the arcsine of x is going to be 1 divided by the square root of 1 minus x squared. And if we apply the product rule, to x times the square root of 1 minus x squared, and think of it as x times 1 minus x squared to the 1/2 power, then we'll end up with 1 minus x squared to the 1/2. The derivative of x was 1. Then we'll have plus x times 1/2 times 1 minus x squared to the negative 1/2 times a negative 2x. That chain rule piece there is pretty complicated. That's what it ends up looking like. So here we're going to have 1 over the square root of 1 minus x squared plus, I'm going to write this as the square root of 1 minus x squared over 1. Then we're going to have minus x squared over the square root of 1 minus x squared. So I'm taking x times 1/2 times negative 2x. Negative 2 times 1/2 is negative 1, so that's where the negative comes from. X times x is x squared, that's where the x squared comes from. And I'm rewriting the 1 minus x squared to the negative 1/2, putting it in the bottom so the exponent is positive 1/2 and rewriting as a square root. So if I put all this over a common denominator, I'll have 1 over the square root of 1 minus x squared plus 1 minus x squared over the square root of 1 minus x squared minus x squared over the square root of 1 minus x squared. And if we start combining things in the top here, we'll end up with 2 times 1 minus x squared all over, I'm going to rewrite the bottom for a moment as 1 minus x squared to the 1/2. So in other words, I saw that we have two 1's, they're both positive. We have 2 negative x squareds. So I can write that as 2 minus 2x squared, or I can factor the 2 out. But now if I divide, I'm going to end up with 2 times the square root of 1 minus x squared. And that's it. That's all the derivative ends up being. Even though we started with a pretty complex looking function, arcsine of x plus x times the square root of 1 minus x squared, we do end up with something fairly simple. Now one of the things that this tells us is that the antiderivative of 2 times the square root of 1 minus x squared is this rather complicated expression here. As you can imagine, that's pretty difficult to figure out, and sometimes just about the only way that we find antiderivatives is by kind of getting lucky and finding the derivative of a function that ends up with the result that we're looking to start with in our integrand.